Section 3.3, we are going to be proving parallel lines theorems that we learned in 3.2, and we're going to also learn about the parallel line theorem converses and postulates. So I'd like to start out with this review. I'd like you to try this, pause the video, try these two problems, and then restart to see if you got them correct. So remember, in question number 1, since you can see the lines are parallel, then we know that if we have parallel lines, the corresponding angles will be congruent. So then we just set them equal to each other, x plus 20 equals 52, and solve to get x equals 32. Since we're going to be talking about all of those theorems converses, it's a good time to review what the converse is. So the converse takes the original hypothesis and conclusion in your conditional statement and it flip-flops them. So the hypothesis becomes the conclusion and the conclusion becomes the hypotenuse. So this the converse of if it is raining, then Josh needs an umbrella, is if Josh needs an umbrella, then it is raining. So we're going to prove angle theorems of parallel lines cut by a transversal and their converses. And we're going to talk about parallel lines theorems and multiple parallel lines. So here's our first problem. It says given that J is parallel to K and M is parallel to N, we want to prove that angle 1 is congruent to angle 3. So I'm going to highlight what we want to prove. Now we already know because these two lines right here are parallel, okay, the alternate exterior angles theorem already says that. But we want to prove it, so we can't use that fact in our proof. We have to go about it a different way. So we're really proving the alternate exterior angle theorem. So we can go about it using another parallel line theorem. That's all. So we're going to start out with our statements, of course, and reason in our 2-column proof. And we're going to, again, like we normally do, start with our given statement. And so we are given that M is parallel to N. We really don't need the other part because we're not dealing with these two lines right here being parallel. That is not going to help us. So not always do you need to put everything in your proof that you are given. Okay, it just kind of depends on what you're proving. Sometimes they give you extra information that's not necessary. Okay, so then the next thing we're going to say is that we are going to say that angle 1 right here and angle 4 right here are corresponding angles, and so when you have parallel lines, just like we saw in that last question, okay, then we know that the corresponding angles are congruent. So we could say that angle 1 is congruent to angle 4, and that is by the corresponding angles postulate. And remember, postulates are great to use because they don't have to be proven. They are accepted without proof. All right, so we know angle 1 and angle 4 are congruent. We also know that angle 4 and angle 3 are congruent. Why do we know that? Well, angle 4 is congruent to angle 3 because they are vertical angles. So that's really vertical angles. You could say definition of vertical angles. You could say vertical angles postulate, okay? Or definition, or just vertical angles is fine. All right, so look at, we have a perfect example of the transitive. We have angle 1 is congruent to angle 4, and 4 is congruent to 3. So notice we start out with what we left off with, and so what we have then is angle 1 is then congruent to angle 3, and that is by the transitive property. Or if you want to use substitution, you could also use substitution. You could say that since 1 and 4 are congruent, you are going to substitute what 1 is congruent to in right here for 4. So since this is 4 and this is 4, you can substitute with 4 is equal to or congruent to in for that. So we just proved the alternate exterior angles theorem. So all of these proofs, okay, if you can, use this corresponding angles postulate. This is going to be kind of the key right here, is we are going to use that corresponding angles postulate whenever we are proving one of these theorems. So that's kind of the key. All right, so now let's work on another one. So now we are given that M is parallel to N again. And what we want to prove is we want to prove that angle 3 is congruent to angle 6. So what angle pair is that? That is the alternate interior angles theorem. So we are proving this theorem. So we can't use that and say, oh, we're done. We just proved it because it's a theorem. Well, that is true, but we want to be able to prove it without using that theorem. We need to go around and prove it a different way. So we'll start out statement, reason, and again, once again, we're going to start with our given that M is parallel to N, and our reason is given. So now what we know, since M is parallel to N, is again, we know that angle, so 3 and we want to prove 3 and 6, so we want to try to use a pair that would involve one of those. So I'm going to use that 3 is congruent to 7. You could use 2 and 6 if you want also, but I'm going to say that angle 3 is congruent to angle 7. Why? What allows me to say that? Well, those are corresponding angles, and we have parallel lines. So again, corresponding angles postulate. So when you have parallel lines, the corresponding angles will always be congruent. Okay, so we also know here, again, that angle 6 and angle 7 are congruent because they are vertical angles. So the vertical angles postulate says so. So we know that angle 6 is congruent to angle 7. Now, depending on how I write that, in the last example, it was a great example of transitive. But here, I would say more so, this is substitution. Because since 3 and 7 are congruent, and I'm trying to prove 3 is congruent to 6, I can substitute what 7 is equal to or congruent to in for 7. So then that means that angle 3 is congruent to 7, but it's also, I can substitute angle 6 in there, and so this would be substitution the way I've written it. Now, if you write transitive instead of substitution, that's fine. Substitution and transitive are very similar, and it kind of just depends on how it's written, which one you might say. All right, here's our next one. We are going to be given again that M is parallel to N, and we want to prove that angle 4 and angle 6 are supplementary. So we want to prove that angle 4 and angle 6 add up to 180 degrees. They're supplementary. That's what we're trying to prove. All right. So we know we have parallel lines. We know we have some congruent angles, etc. So again, we'll write our two columns. And we'll get started with the given. So M is parallel to N. Okay, so again, we also know that angle 2 and angle 6, so angle 2 and angle 6 are congruent because of the corresponding angles again. Whoops. So step number 2 is angle 2 is congruent to angle 6. And again, that is the corresponding angles postulate. And we also know that angle 2 and angle 4, we know that angle 2 and angle 4 are supplementary. So angle 2 and angle 4 are supplementary. How do we know that? Well, that is by definition of a linear pair, or that is our linear pair postulate. And we might put in here a second step. We might actually put in a linear pair / supplementary. And we could say definition of linear pair or linear pair postulate. So we'll just put linear pair postulate or definition. And that could be two separate steps if we really wanted to get nitpicky. But again, for where we're at right now with proofs, I think that's fine. Okay, so now we also know, since 2 and 6 are congruent, we can substitute what 2 is equal to in for this 2. So then what that means then is that angle 6 and angle 4 are supplementary, and that would be by substitution. And, you know, you could do this proof many different ways. You could actually put angle 2 plus angle 4 equals 180, etc., and then substitute and set the 180s equal to each other and use a subtraction property of equality. So there's many different ways to do these proofs when you're doing proofs. But I'm trying to simplify it a little bit, and hopefully you could see sort of the flow of these proofs so far. But what I've been trying to show you is that this corresponding angles postulate is kind of the key to how we go about proving any of those parallel lines theorems. So here is, again, what I'm saying about that is that the corresponding angles postulate and its converse are the key to all of these proofs that we're going to be doing. So our corresponding angles postulate said if two lines, it's down here, so here's our corresponding angles postulate. If two parallel lines are intersected by a transversal, then pairs of corresponding angles are congruent. So the converse here says the opposite. It says if two lines are intersected by a transversal such that corresponding angles are congruent, then the lines are parallel. So here's the difference. In the first one, we are given these parallel lines. So this is parallel lines are given. And what results is that the corresponding angles are congruent. What's different here is we are not necessarily given parallel lines. We're given two lines. They're not marked parallel, but they're intersected by this transversal right here. So you have these lines intersected by this transversal, but what you are given in the converse is that these corresponding angles right here, so these angles are congruent. So this is our given right here. So these are given. And when you're given that, then what it leads to is that our lines are parallel. Okay, so that's the difference, is that you're given that the angles are congruent and it leads to parallel, versus in the original one, you're given parallel lines, which means they're congruent. So this is all of the stuff that we worked on with the conditional statements and converses. It's because a lot of the theorems that we are going to study and learn have converses. So you really only need to memorize that first theorem or postulate and then just know that there is a converse, and you can just flip-flop it around. Okay, well, it turns out all of our theorems here basically have converses. And so the alternate exterior angles converse says this: if two lines are intersected by a transversal such that alternate interior angles are congruent. So we're looking at what we're given is that alternate interior angles are congruent. This is what we're given. And then the lines are parallel. So again, what we're given is these two lines intersected by this transversal. And what we're given is that the alternate interior angles are congruent. So this is given, is that alternate interior angles are congruent. So then what we have is parallel lines. Okay? And maybe I could have cleaned up that last one, but again, you're just trying to understand the converses here of those original theorems. And then the same is true for the converse of the alternate exterior angles theorem. So here what we have is it says, if two lines are intersected by a transversal such that alternate exterior angles are congruent, so this is our given. We have these two lines intersected by this transversal again, and we don't know they're parallel, but if we know that these alternate exterior angles right here are congruent, so when we're given that alternate exterior angles, and you don't have to abbreviate that, but if we're given that, then what we conclude, we have parallel lines. All right, so hopefully that's making sense. And consecutive angles converse, okay, similar to what we had before, only these aren't going to be congruent, they're going to be supplementary. So in this example, what we are given is we are given lines intersected by a transversal such that consecutive angles are supplementary. So here's our lines, again, intersected by this transversal. And so now what we're going to be given is we're going to be given that, like, this angle is 95 and this angle would be what, 75? Nope, 65, I believe, if I can do my math right. So that's 150, that's 160, no, 170, it was 75. Okay, so if we can see, that's 160, 170. Boy, I still don't have it right. That's supposed to be 85. All right. Well, if they're supplementary there, okay. So add to 180. So 95 plus 85 equals 180. So we know they're supplementary. That's our given. Then the lines will be parallel. All right, we have one other theorem to talk about that we haven't yet, and that is the transitive property of parallel lines. And what it says is, if two lines are parallel to the same line, then they are parallel to each other. So here's a line, okay? And if this line right here and this line are parallel, and you have another line, so these two, the red and the green, are both parallel to the same line, then they are going to be parallel to each other. So now what that means is that this line right here is parallel to this line right here. And it kind of makes sense. I don't think that's something that is difficult for you to understand. All right, I have a quick example, and then that'll be the end of the lesson. It says, find the value of x that makes the lines parallel. So these lines are not marked parallel, but what value of x would make them parallel? Well, it would be the value of x that makes these two congruent to each other, because if corresponding angles are congruent, then the lines will be congruent. So we are going to set 3x plus 5 equal to 65. So then we get 3x equals 60, and x equals 20. So x having the value of 20 would make those lines parallel. Next question asks, is there enough information in the diagram to conclude that the lines are parallel? Well, we are given that this angle is 75 and this angle is 105. Okay, well, we don't have an angle pair relationship for those two. So you might initially say no, but what else do you know? Well, you know that these two lines right here make a linear pair. So if this one is 75, then this has to be 105. And now what you have is you have corresponding angles. So corresponding angles are congruent. So yes, M is parallel to N. So sometimes you're not given the information, but you can get it from linear pair, or you could have gotten this actually from vertical angles right here. If you use this vertical angle right here, okay, and you use this vertical angle right here, now you could say that because of consecutive interior angles, the lines are parallel. Let's see if I can write this better. Or consecutive interior angles are congruent. So M is parallel to N. And you probably could have proved it another way.